Now, the next thing that we are going to explore is the value a. Notice that in our equation, a is this value. What is the effect of this value to the graph? Let's take a look at this. From the mother function y equals sine of x, which is this red graph, if we multiply the function by 2, as represented by this constant 2 times the sine of x, notice that the height of the graph becomes 2. When I say the height is from the midline of the wave going to the peak. The peak is this, and this length is 2 units, and that is the same as this number 2. And at the other side, you also have negative 2 going down here. So therefore, whatever is the absolute value of a, that represents the distance from the midline of the wave going to the highest point. So the distance from here going to this lowest point is twice the absolute value of a. Or from this point going to the midline is this value a. Now, if the sign of this a is changed from positive 2 to negative 2, the effect of that would be to reflect the graph vertically. That means this point is reflected to the other side, this point is reflected to the other side, so the new graph would look like this. So we call that as vertical reflection. It's like you rotate this to go to the bottom, in this bottom you rotate to go to the top. Now the amplitude is the height from the center line to the peak, or we can measure the height from the highest to the lowest point and divide by 2. So the amplitude or the height of this function is 2 units, and you can detect that by just looking at this number that is multiplied to the sine function. In here, notice that I multiplied the sine function by 3. Notice now that the height is 3 units. From the center line to the highest point is 3 units. And if you are going to combine now all these different changes in the amplitude, the graph of y equals sine x is this red graph at the middle. The graph of y equals 3 sine x is this graph that's the tallest. The graph of y equals 2 sine x is this blue graph. And when we change the sign from positive 2 to negative 2, we reflected this blue graph to appear like this green graph. Those are the effect of changing the value of a in our equation. Now, a while ago, I said that the period of the sine function is the length in the x-axis in order for us to complete one cycle. So the wave that I trace green is one cycle, because after this point, it's just a repetition of the same shape. In other words, the wave is composed of a lot of cycles. And this one cycle is 2 pi. And that is the period of y equals sine x. But this period will be affected if there's a number that is inserted between the sine and this x. Now, what is the effect of this number that is inserted between the sine function and the variable x? Instead of having sine x, we now have here sine of 2x. And this 2 is the letter b in our formula. Now, let's look first at the red graph. So from here, from this point to that point, we have 360 degrees. 360 degrees is the period of the sine function. Now, if we have sine of 2x, the graph of that would be this blue function. Notice now that if you are going to trace the blue graph from here going to this point, going to this, that is one cycle. And then let's repeat that cycle now here. And from here going to that point is another cycle. In other words, from this point going to this point, we now have 2 cycles. We now have 2 cycles in the span of 360 degrees. In other words, we can find the number of cycles of the graph y equals sine of 2x by using this formula. 360 divided it by whatever is this number, divided by 2, we will get 360 divided by 2, 180. This 180 becomes now the period of this new function. So the period now is the length in the x-axis to complete one cycle. And the function y equals sine 2x has a period of 360 divided by this 2, which is 180 degrees. And you can now think of this number 2 as the number of cycles in 360 degrees or 2 pi. So from the period from 0 to 360, there would be 1, 2 cycles. Or another way of naming these two is we call that as the frequency. Notice that in your radio station, we have what we call as the frequency of the FM station or the frequency of the AM station. That refers to this number of cycles per unit of time. So if we now have y equals sine 3 times x, from here, we can know that the period of this graph would be 360 divided by 3, which is 120 degrees. So from here to 120 degrees, that comprise one cycle. And that is the period. The period is the length in the x-axis in order for the wave to complete one cycle. And the number of cycles from 0 to 360, the period from 0 to 360, this is 360, not this one. So from 0 to 360, there would be 3 cycles. Let's verify that there are 3 cycles. So you have 1, you have 2, and you have 3 cycles. So by looking at this graph, you know that this 3 represents the number of cycles for every 360 degrees. And 360 divided by this number would be the period. And the period is the length for the wave to complete one cycle. So putting them all together now, if you have y equals sine 6x, notice now that this 6 means that we will have 6 cycles in the period from 0 to 360. And we can verify that. 360 is this point. Let's count the number of cycles. You have 1, you have 2, you have 3, you have 4, you have 5, and you have 6. And what is now the period of sine 6x? The period is 360 divided by 6, which is equal to 60. And 60 is this point. So the period is 60 degrees. That is the length in the x coordinate for the wave to complete one cycle. And here's the definition. Frequency is the number of cycles it completes in a given interval. So in a given interval, let's say from 0 to 360, we have 6 cycles, and therefore we now say that the frequency here is 6. In the sine function, that interval is generally 2 pi radians or 360 degrees. So to generalize that observation, we now define period as 2 pi over b, or in degree measure 360 over b. This gives us the period of the sine function. So to summarize all our observation, whenever we are graphing a sine function, we want to transform it so that it looks like this, where this a represents the height of the graph. So the height is this height. This b represents the number of cycles in 360 degrees. This c represents whether you move the graph to the left or move the graph at the right without changing the shape of the graph. And this d represents the vertical shift. Either you move the graph or you slide it down without changing the shape of the graph. For the terms, we call this a as the amplitude. We call 2 pi over b as the period. This d is what we call as the displacement or the vertical shift. And this c is what we call as the horizontal shift or the phase shift. So those are some of the properties of a wave that we can study analytically. Apply what we learned so far. If you are given the function f of x equals 2 sine of x plus 45 plus 1, what can we deduce from this form? We know that the amplitude is the absolute value of a, and the absolute value of a here is the absolute value of 2, which is 2. So we know that the height of the wave is 2 units. Now, what does this plus 45 means? We said that if this is plus, the graph is going to the left. So that means there is a phase shift of 45 degrees to the left. This one is the vertical shift that is positive. That means the graph is moving up 1 unit compared to the graph of the mother function, y equals sine of x. Now the period is 2 pi over b or 360 over b. But there is no number b here. So that means b is implied to be 1. So that means you have 360 over 1 equals 360. That is the period 360. And let's now sketch the graph. In the graph, looks like this now. The red graph is the graph of y equals sine of x. And the blue graph is the graph of this formula. Notice now that the graph is push 1 unit up. It's push 1 unit up. It's towards the upper part. And the graph is shifted a little bit to the left, which is this 45 degrees. And the period from this point to complete one cycle is to see the same positioning here. Like I started a little bit going up, I will end at the same position a little bit going up. So what is now the length of this in the x-axis? That length is the 360 degrees, which is the period that we have just computed in the previous slide. The graph is translated a little bit up by 1 unit, and the graph is translated a little bit to the left by 45 degrees. And the graph is stretched vertically to have a height of 2 units compared to the graph of y equals sine x. So at this point, we are now ready to answer our math problem of the day. The problem that was given was, the height of water in a wave pool oscillates between a maximum of 13 feet, so this is 13 feet, and a minimum of 5 feet, this is 5 feet. The wave generator pumps 6 waves per minute, so 6 waves per minute. If there are 6 waves per minute, that is equivalent to having 6 waves per 60 seconds, or 1 wave for every 10 seconds. So we need to remember this. The graph of the sine function is in the form f of x or y equals a sine b x. Let's determine what is a. So the midline here is at 9. The length from here going to the highest point is 13 minus 9, which is 4. From this point going to the lowest point 5 is also 4 units. So that means our a is 4. Notice that the graph should be centered at the point of origin, but now the center is at this point. And what is that displacement? That is 9 units up. So our d is positive 9. Notice that the center point still at the middle, so there is no horizontal displacement. So that means our c is equal to 0. Now, how do we determine the b? We said that the period of the graph is 2 pi over the b. That is equal to the period. Or similarly, we have 2 pi over the period is equal to the b. But a while ago, we said that there is 1 wave for every 10 seconds. So it takes 10 seconds to complete 1 cycle. That means our period is 10 seconds. So using now this formula, we will have 2 pi over a period of 10 seconds. That would be equal to our b. And that is 2 pi divided by 10. We can cancel out the 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Our b, therefore, is equal to pi, 1 times pi is pi, over 5. So the number that we are going to substitute for b is pi over 5. So that means now that the graph as described in this problem is in the form y equals, our a is 4, copy the sine function, our b is pi over 5 times x, our c is 0, so we don't have to write that anymore, plus our d is 9. When you graph this sine function, you will notice that you will get this graph. So that's how we solve our math problem of the day that involve transformation of the sine functions. So this video is getting longer now. We would like to invite you to go to the next video where we are going to give several examples as an application of what we discussed in this video. Thank you very much.